Good evening, everyone. Today's session is on octal and hexadecimal number system. Here we are going to learn about like how we convert the numbers into different formats into different number system. So basically, in my previous session, I have discussed about what are octal numbers, what are hexadecimal numbers, what are binary numbers, what are decimal numbers. So based on that, we are going to apply the formula, right? And how we derive the basically octal to any number, like octal to hexadecimal or octal to binary or hexadecimal to octal or hexadecimal to binary, right? So let us begin with the session. So first of all, this is the formula which we are going to use for any number. Like if I'm talking about a decimal number especially, we know that the base of decimal number would be 10 because the digits has the options that is 0 to 9. So you have 10 options and this base the number should be less than this base. So these rules I have already discussed in my previous session, right? And suppose I'm talking about an octal number that has its base that is 8, and that means your number would be lying between 0 to 7, again less than your base. The last digit should be less than your base. And then we have binary number. In binary we have the base that is 2, right? And again there are only two options, 0 and 1. Again it should be less than your base value. And then we talk about the hexadecimal. Now whenever we talk about hexadecimal, the base of any hexadecimal number would be your 16, right? So you have a combination of from 0 to 9 and then A to F. That means your A would be 10, B would be 11, and so on. So the last F would be like 15 is representing the F, and that is again should be less than your base value, that is 16. So this thing we have already discussed. Now let us see what is the method we are going to use when we are going to use the successive division and when we are going to use the weighted multiplication. So basically these are the two methods for the conversions, and it could be between any of the number system. It could be between decimal to octal, it could be between decimal to binary, or it could be between decimal to hexadecimal number. So here what we are going to use, we are going to use two methods for basically doing the conversion part. So if we are converting a decimal to a octal, we might be using multiplication or we might be using division as per the conversion method. Now let us start with some numericals. So before starting with the numericals, we need to understand like what are the binary representation of each of the number system. So this is, we know that the base of the decimal number is 10, the base of the binary number would be your 2, the base of the octal number is 8, and the base of the hexadecimal number is 16, right? So here we have different numbers and the basis I have given. Now the main part, how to derive the binary number for like for representing 0 or for representing 1, 2 and 3. So the simple method is for students to learn about like how to go about it, how to learn the binary representation of any number. You have to learn only these four numbers. I would be telling you about how what are the four numbers: 00, 01, 10 and 11. So if you know this series, you can derive any of the binary number, right? So the series would be representing like this: 00, 01, and then 10, and then 11. Right. Now how we are going to derive any of the number? We can see that 0, you put 0 in front of that, right? Then 01, then 10, and then 11. So this series I have followed. I will be following this series throughout the number system and for binary representation, and accordingly we are changing the next two digits, that is here 00. Again I will take the first combination with all these three with 00 first, The same thing I would be following. Then I would be taking 0 1 for the same series. Then I would be taking 1 0 for this series. Then I would be taking 1 1 for complete. So next two digits of this particular digit, like this is 0 0. Now you have taken as 0 1. So all in all the next four numbers you will get 0 1. And the same series would be followed like 0 1, 0 0, 0 1 and 1 0. And then we have 1 1. Again, now you have completed with 0 1 part. Then after 0 1 you will get 10. So here you will be getting 10. Complete this series 10 and apply the same series 0 0 0 1 1 0 and 1 1. Then the last number would be your 1 1. Right. Then again 4 digits, next four numbers and taking the four numbers like this. So this is how we derive the binary number of any number. So there is no need to learn, no need to like have a confusion in that. You just need to remember the first four digits, the first four numbers like 0 1 2 and 3. Rest all can be derived from this series only. For like this we have, you can see I have only reached up to 15. So our hexadecimal would be representing like your 16 number would be representing like F would be representing in the binary form like this. So this is the binary representation of this F part, right? Or you may say the hexadecimal number. Now let us move to the next part. I have explained in the first slide like how you are going to use for whenever you are converting any decimal number into the base of any number. It would be binary, it could be octal, it could be anything. So you have to use the formula that is successive division. And if you are converting any base form to decimal number, it would be in your multiplication form. Right? So let us revise this thing. Let us see the main points. Divide the decimal number by 2. Why 2? Because we are converting into the binary number. So the base of binary number would be 2. The remainder is the LSB of the binary number. If the quotation is 0, the conversion is complete. So at the end, if you get 0, your quotation will be complete. Otherwise, we need to repeat the steps until and unless we are not getting the 0 point something like this. Right? So here what we can do is like your new remainder would be the last bit, right? The new remainder of the next last bit means the whenever you get the last part of the remainder, that is called, and you move from bottom to top, you are not following top to bottom. So there are some rules like I have told you for positioning any system with 0 1 2 or 3. So we move from right to left. Here also we are moving from bottom to top, right? So here the next thing is base 2 and base 10. So base 2 means binary representation of any number, and you are going to convert it into base 10, that is decimal representation. So what you are going to do, you are going to multiply that particular number with the 2. Right. So let us start with some examples so that we may have a clear idea on any of the numbers. So here I would be saying like whenever we are converting decimal into any base number, we will be using the division part, and the vice versa of this. If you are converting any base of any n means it could be your octal, it could be your binary, it could be your hexadecimal. So you can take any base, but these are the two formulas. Like you might be taking, you might be converting decimal to any of the conversion, any base. So you have to take the division part. And for converting from any base to the decimal part, you have to use the multiplication. These are the basic two rules. You may say these are the basic concepts for the conversion. Right. So let us take some examples. Starting with the first example, very first example, you have the decimal number right? And you need to convert it into a octal conversion. So here I told you, whenever you are converting a decimal number to an octal, that means you will be using the division formula, right? The process would be division, but by what? By which number? By what number? That is the base of for which you want to convert it. So the base of octal number would be your 8. So you are dividing the whole number with 8 until and unless you get the 0 point something, like remainder would be your 0 something. So let us see the first example. So here what we are doing, convert the decimal number, that is 94. How you are going to understand that this is a number, that is a decimal number? You can easily identify that number with the help of the base. So if the base is 10, then it would be a not binary, because sometimes students get confused. It's a representation of 1 and 0. So it would be a decimal number because we have the combination from 0 to 9. In case of binary number, we have only two combinations. Either the bit is 0 or the bit is 1, right? And the base would be your 2. Right. Then we have octal equivalent number. So octal number are represented. What is the base for octal number? That is 8. Right. Now let us start with the calculation part. How we are going to calculate. So we have the number that is 94, and that is because it is a 94 and it's a decimal number. Right. We can easily identify with this part also. You will be dividing this number with the base 8. Why 8? Because we need to convert it into an octal number. So octal numbers are having the base 8. 94, here we are getting 94 divided by 8. You will get the quotient, that is 11, and you will get the remainder, that is 6. Again, if your quotient is some 11 or not equal to 0, right, until and unless you are not getting 0, you have to divide it. You have to repeat these steps. So 11 you would be getting, 11 is divided by 8, and then your quotient would be 1, again not equal to 0. Then so in this case you will getting the remainder, that is 3, right? Again in the another system, you have to 1 divided by 8. So now here you will be getting 0 point something, like any number. But what we do is we usually take this bit as the last bit whenever we get 1, or you may say if it is 0, we can stop that process and we can take this bit is the most significant bit. And whenever we derive any number, we follow the process that is bottom to top. So you are taking from bottom, you are writing the conversion into this form, and again I am repeating, this bit is called most significant bit and the topmost bit is called least significant bit, right? So last part, it is MSB, or we can call it as most significant bit. The first part is LSB, that is least significant bit. Now here we get out 1, 3 and 6, right? Now what is this 1, 3, 6? Because we have divided with 8. So that means this is an octal representation for the number, that is a decimal number of 94 with the base 10. So this is the first example. Let me give you one question. Let me give one question on this. So you have the decimal number. Now you need to convert it into an octal number. The same process you are going to follow. 189 divided by 8, until and unless you are getting 0 as a quotient. So let us see the solution also. So here we have the decimal number, and then for which we are going to use the process of division. So whenever I told you, whenever we have to convert a decimal number into any of the form, like any of the base, you are going to divide that number with that particular base. If it is hexadecimal, you will be dividing it with be 16. If it is a binary number, you would be dividing it with 2. So basically based on the equivalent, you need to identify which number you are going to use for division. So you are using octal. So here 189 divided by 8, you will be getting a quotient of 23 and the remainder, that is 5. right? Again, what you have done, you have taken 23 divided by 8, and you will getting the, again you will getting some quotient that is not equal to 0. So again you have to repeat the step. You are getting the remainder as 7, right? Then you have taken 2 divided by 8. So here you will be getting something 0 point something. So what you are going to do, directly take it as a MSB, because now division cannot be possible. So this is the most significant bit, right? And again the same process, 275. This would be your octal representation for the decimal number, that is 189. So this is how we use the number system. This is how we use the different bases. And in case like you are why you are, what process, which concept you are using the process of division, right? Now let us take some more examples. In case when you have to convert not with the decimal part, now what you are going to take, you are taking any base and the base would be your 8. Now you are basically converting into a decimal number. Now what you are going to do, we are going to use the process that is called weighted multiplication, right? Now here we are going to multiply with that particular base, right? Now your base number is 36. Now you need to convert into a decimal point number. How you are going to do? You have to write like this. Again, position it from right to left. This has the position 0. This has the position 1. This has the position 2. Right? And what is the base? Base you would be using 8. So 8 to the power 0 into 6 plus 8 to the power 1 into 3 plus 1 8 to the power 2 into 1, and add all these things, you will be getting a decimal point number, right? So this is the bit weighting factors, how you are going to give the weight to each of the factors. So basically here it is not written, I have given the solution to it. This is 3 into 8 to the power 1. This is 1 into 8 to the power 2. So add all of these values, 6 into 8 to the power 0. Then you would be getting this answer, that is the decimal point. Yeah, then you will be getting this answer, right? So here we have the octal representation, and the number which we are getting is the decimal number, right? So which method we have used? We have used multiplication. Have you seen? I have not divided anything with any number. I have used? I have used the weighted multiplication part. Whenever we have any base and we try to convert it into a decimal number, what we are going to do? We are going to use the multiplication method for that, right? Let us take more examples. This is the next example. Now, how to convert it? Now it is very easy, because 1 into 8 to the power. Then how you are going to decide it? Let me tell you. 3 into 8 to the power, then plus 4 into 8 to the power. So here we have, from here we have to move from right to left. So what is the position of this? What is the weighting factor? That is 0. Then we have 8 to the power 1. Then we have 8 to the power 2. Right? And then it will be giving us the decimal equivalent number. So let me show you the solution for that. So this would be your solution for the conversion, that is octal number to a decimal number, right? So here we have to multiply 3 into 8 to the power 1, 4 into 8 to the power 0, 1 into 8 to the power 2, and add all these values. So we will be getting a decimal point number, that is 92. That is equivalent to octal number of 134, right? Now let us take another example how we can convert. That's, we have taken two examples of octal number, how to convert from decimal to octal and then octal to decimal. Now let us take another example which is going to convert decimal to hexadecimal, and again hexadecimal to decimal. How to convert it, that part, let us see the process. So I told you, whenever we have to convert it from decimal to hexadecimal, we will be using the division part, division concept. The process would be division, and as we have hexadecimal number, the base of hexadecimal number is 16, so you would be taking the division by, division process will be taking place by dividing the 16, divide that number by 16. So we have taken the number that is a decimal number, and now we want to convert into a hexadecimal number. So 94 divided by 16, the quotient will be 5 and your remainder would be E. Why it is E? So basically, let us understand this concept also in a rough work. 10 is representing the value in hexadecimal is A. Okay? 11 we have for B. 12 we have for C. 13 we have for D. 14 we have for E. And 15 we have for F. Now let us see why it is taking as E. How it understands E. So basically E is 14. Your remainder would be 14 here. That's why it has taken, because it does not understand after 9, 0 to 9 digits. It would be taking as alphabets from 0 to F, that is completing your 15 digits, and the base value is 60. So it should be less than your base value, that is 15. But what is the symbol that we use? What is the number that we use in place of 14 is E in hexadecimal representation. So that's why we have taken E here. And then we get the quotient 0 here. So that means this is the last bit, fifth. So we are writing like this. Your 5E would be the answer. The hexadecimal representation of this decimal number, that is 94. Right? Let us take another example. So we have 429 here. Let us see the solution also, how it is going to convert it. So we know that this is a decimal number, needs to be converted into hexadecimal. Again, the base would be your 16, and because any number is like decimal number is converted into hexadecimal, that means we need to follow the process of division, right? So what we are going to do, we have to take 429 divided by 16, you will be getting the quotient 26, and the remainder would be D. Now what is D? D I have already calculated. What is the value of D? That is 13. So that means your remainder would be 13 in this case, that is already converted into D. Now in the next, 26 divided by 16, you will be getting 1, again not equal to 0. So the remainder would be 10, right? And what is the representation of 10? That is A, right? And then 1 divided by 16, you will be getting 0 point something. So that means this is the last bit, that is most significant bit. So again, process from bottom to top, you will be getting 1 A D. So 1 A D is the hexadecimal representation of the decimal number. You may write it like H also, because sometimes the people may write like this. It is the right representation. H is basically representing the hexadecimal number system. Now let us complete it, the last part, that is hexadecimal to decimal process, right? So again, any base decimal, which process we are going to use? We are going to use the weighted multiplication process. right? We will be using weighted multiplication process. So here we have an hexadecimal number, that is 5e. That is 5e. We need to convert it into a decimal number. We need to convert it into a decimal number. So how we are going to do it? We have to basically take the 5. What is the e representation of hexadecimal number? That is 14. So we will be taking 14, right? 14 into 16 raised to the power 0 plus 5 into 16 raised to the power 1, right? And then we convert it into a decimal point. So this is very easy part, like when you are going to convert an hexadecimal number into a decimal number, right? Again, b would be your 11, right? 11 into 8 raised to the power 2, and 2 into 8 raised to the power 1. E would be your 14. So 14 into 8 raised to the power, that is 16, sorry, 16 raised to the power. It would be, because it's a hexadecimal number. It is not octal number. So 16 raised to the power 2 into 11 plus. So here I am going to solve it. Let me give the solution part also. Because it's a hexadecimal number, we will be having the base, that is 16, right? So E would be your 14, right? The 14 into 16 raised to the power 0, right? Then plus 2 into 16 raised to the power 1. Again B, 10 is your A, to 11 is your B. So 11 into 16 raised to the power 2, and then add all these values. So this is very very important. Weighting factors are assigned from right to left. This is 0 position, this is 1, and this is 2, right? So by adding all this value, you will be getting the decimal point number, that is 2862, right? So basic concept behind the number system in this part, we have, first of all, uh, we need to understand what are the bases, how many numbers we would be having, and then we convert it. So the best way, like whenever you get any question related to number system, first of all you need to convert it into a decimal number, then you can convert it into any of the base. So I will be telling you more examples. We will be having more sessions on this part when we have multiple conversions, like we are going to convert a decimal number to a binary number, and then binary to hexadecimal, and then we have, or anything like octal number to hexadecimal, right? So we will be using these methods only, multiplication and division methods. So I hope you have understood how we have derived these number systems, how we have derived the decimal equivalent, how we have derived the octal equivalent or hexadecimal equivalent. So we have completed with this part, right? And I have solved multiple examples I have given you. Hope you have understood what is number system. Hope you like the session, right? Thank you.